विद्यार्थी मित्र, आजपासून आपण 12वीचा सिलेबस सुरुवात करत आहोत. आपला पहिला टॉपिक आहे रोटेशनल डायनॅमिक्स. बेसिकली दिस रोटेशनल डायनॅमिक consists of two topics as per the old syllabus. The first topic is a circular motion and the second topic is a rotational motion. By combining these two topics, a rotational dynamics is formed. So we will see the first part of this topic, that is a circular motion. This circular motion I have taught to you, but just I will take a revision to this circular motion so as to educate with the next part of this topic, that is a rotational motion. So circular motion, it is a motion of a particle or body along the circumference of a circle, that is called as a circular motion. There are so many examples of a circular motion. So see this is a circle, this is the center of the circle, and this is the particle. As this particle moves along the circumference of the circle, the motion of this particle is known as a circular motion. So in a circular motion, there are so many examples in nature. The first example is a motion of a satellite around the earth is a circular motion. Motion of earth around the sun is a circular motion. The motion of tips of minutes hand, hours hand, seconds hand in a wall clock are circular motions. So while studying the circular motion, we have to see some basic terms in the circular motion, and the basic term is a radius vector. What is meant by radius vector? Radius vector, it is a vector which starts from the center of the circular motion and ends on a circumference of the circle, that is called as a radius vector. Or in other words, we can say that radius vector, it is a vector which starts from the center of a circular motion and ends on the circumference of the circle. So this is the center of the circle from which this radius vector starts and it ends on the circumference of the circle, that is called as a radius vector. It is directed from, as it is a vector quantity, it has magnitude as well as direction. Its magnitude is exactly equal to the radius of the circle, and its direction of radius vector is directed from center to the circumference of the circles, that is called as a radius vector. Another similar term to this radius vector is a position vector. If the center of circular motion and the origin of x-axis and y-axis coincides with each other, then this radius vector is known as position vector. See once again, if the origin of x-axis and y-axis coincides with the center of circular motion, then this radius vector is known as a position vector. Every position vector is a radius vector, but any radius vector cannot be a position vector. Only when the origin of x-axis and y-axis coincides with the center of circular motion, then such a radius vector is known as a position vector. So we will see what is the importance of position vector. Position vector always describes the position of a particle in circular motion. If we plot the diagram for a position vector, the diagram is as shown in figure. So this is the center of circular motion, and particle is performing the circular motion along the circumference of the circle. So at a particular position, x comma y, This position vector makes an angle theta with the center of circular motion, and this radius vector is resolved into two components. How this vector can be resolved? So, drop a perpendicular on x-axis and y-axis from the point P. This distance OA will give the magnitude of vector R along x-axis, and this OB will give the magnitude of resolved component of vector R along y-axis. In this way, single vector is split into two vectors, that is OA and OB. According to triangle law for vector addition, the addition of these two vectors, vector OA and vector OB, will give the position vector R. So, here, if we use a triangle law for vector addition in this figure, then vector OA plus vector OB is equal to vector R. But vector OA is equal to Rx, which is the magnitude of this vector OA. This magnitude multiplied by unit vector, that is I. Similarly, OB is equal to Ry into J, that is Ry is the magnitude of vector OB and J is the unit vector along y-axis. So, if we substitute these values in equation 1, we will get the position vector R is equal to position vector R is equal to Rxi plus Ryj. So, this is a position vector for this circular motion. But from figure, Rx is equal to R cos theta, that is equal to R cos omega t, and Ry is equal to R sin omega theta is equal to R sin omega t. So, if we substitute this value in equation 2, the position vector will be vector R is equal to R cos omega ti plus R sin omega tj. So, this is a position. So, what is the importance of this position vector in circular motion? Position vector describes the position of a particle in circular motion. At the same time, it gives the displacement of the particle from the reference position. So, this is the linear displacement of the particle from the reference position. So, this is the importance of this position vector R. So, if we differentiate this equation R, we will get velocity. So, if we would like to find the velocity, then velocity V is equal to dr by dt. If we differentiate the position vector R, we will get the velocity which is always tangential to the circular path. Again, if you would like to find the acceleration, that is a linear acceleration in circular motion, then it will be given by A is equal to dV by dt. So, it means from the position vector we can calculate velocity, acceleration, that is a linear acceleration in circular motion. So this is the importance of position vector. That position vector is a very important term.